There's another argument made about the flat Earth from air travel. Flights across the United States, either east to west or west to east, take similar amounts of time. But according to some flat earthers, if the Earth were spinning, having equal travel times is a challenge to the spherical Earth.
Commercial air flights do about 530, 550 miles per hour. So if a plane takes off from the west coast, if it's flying to the east coast, it's going to lose ground the whole time because the Earth is spinning away from it faster than it can fly, so it's going to lose ground. On the other hand, flights from the east coast to the west coast ought to be really fast. Or for that matter, all you have to do is just hover in a helicopter in New York and just hover for 3 hours. The Earth will rotate, and then you can land in San Francisco.
But obviously that's not the case. And so some claim this is proof that the Earth isn't actually a spinning sphere. However, the answers are found in the laws of motion and momentum.
Would you like something to drink?
Oh, whoa, where'd you get that? That's cool.
Some nuts?
Oh, wow, what, like an airplane. Wow, yeah, sure.
I'm your
Sounds good.
stewardess.
Or steward.
I guess that's true. Yeah, I'm a steward. Well, here, let me pour this for you.
Okay.
By the way, you know, flat earthers all the time talk about if we were actually on a ball, on a globe, with it going 1,000 miles an hour, that we should be able to feel it.
Yeah.
But Kyle, since we're an object in motion, an object in motion wants to stay in motion.
Right.
And so even just now as I'm pouring this for you,
Yeah.
you can tell that it's not going towards the back of the car, it's going straight down. It's because it's already an object in motion. And likewise, here on the planet, we don't feel the motion because we're objects in motion. Okay, also I've got a quarter right here, and watch, when I flip the quarter, it just goes straight up and comes back again.
Yeah.
It's not going against the back windshield.
Well, I'm so thankful for that.
Right, exactly. Do this in a moving car, it's going at 60 miles an hour. In that half second that the coin is in the air, the car will have moved 44 feet. No way is it going to land back in your lap. It's going to fly back 44 feet behind you and probably smack the guy in the head behind you in the back seat. Try doing this on an airplane traveling at 500 and some miles per hour. If you just flip a coin, it's suddenly going to go flying back at 500 miles an hour, and the poor sap in the back of the plane is going to get killed by this penny you've just flipped. Or imagine a flight attendant trying to pour you some coffee or some water, or soft drink or something. It's going to go flying back at 500 and some miles per hour if the plane's really moving at 500 and some miles per hour. Obviously, that doesn't happen, because you see what happens is the plane's moving forward at 500 miles per hour. The drink is moving at 500 and some miles per hour. It's got what we call momentum, and unless you have a force acting upon it to change that momentum, it's going to keep moving forward. So when you pour it out of the container into the cup, it just drops right down because it's going to continue its forward motion. Ditto for the flip coin. Ditto for the plane that takes off in San Francisco. It's moving 700 miles an hour to the east along with the atmosphere of the Earth, and so it's going to fly with respect to the atmosphere of the Earth, and then it lands. When objects leave the ground, they don't magically lose their momentum. They maintain their momentum.
It's like us being in the car, we've reached a certain momentum. Even though we're traveling, we can't feel it. In the same way, the Earth is rotating at 1,000 miles per hour.
That's correct.
But we don't feel it because it's so big and we're a part of it.
Right, and we're already a body in motion that wants to stay in motion.